Hello everyone. So today we are going to solve one very interesting numerical of first year PUC class 11 chapter number 5 laws of motion. A mass of 1 kg is suspended by string A. Another string C is attached to the lower end of that mass like this. This is one mass, one string, another string. This is string A, mass B, and this is string C. This is the situation. In this case, if sudden jerk is applied, means here one force is applied like this. Okay, sudden force. Jerk means sudden force is applied. So which portion of the wire will break? Options are the portion AB will break first. The portion BC of the string will break. This will break, or no string will break, and the mass will start rotating. Out of these four, which is the answer? So the mass will start rotating. So for rotation we should give couple. Okay, two opposite forces we should apply. Okay, like this. So one on this side, one on this side, but force is applied like this. So it will not rotate. There is no question of rotating. So option number 4 is not the answer. Surely. Okay. None of the string will break. If the string is sufficiently strong, then it can bear the load. Whatever jerk, whatever load, whatever may be the type of load applied. If the string is strong, it will not break in that case. But let us assume the force applied is much more, jerk or whatever, it is going to break. But which will break, that is the question. Okay, so we will not consider this option also. Surely this option is not there. This option we are not considering. But out of these two, so some people have given this as answer, some have given this as answer. On internet also I searched. Okay, so one of my students asked, sir, both answers are given, which is the correct one? So I thought I should perform experiment on this. Before going for experiment, okay, we will discuss first. Suppose if some load is applied here, okay, some load is applied, additional load we can apply, or by hand also we can apply some load on this wire. Okay, so what will happen? In this case, what will happen? Tension will be developed in the string. Here, this tension and this tension. This tension will be more. Suppose T is the tension developed in this wire C. Here, this load, this force plus this, okay, this tension is equal to force. This much is the tension developed in this string. But here, this force plus 1. So here, this tension is equal to what? This tension is equal to what? Tension A, let us say. This force plus this 1 kg, 1 into G. This much will be the force, this much will be the tension. It is more. This much is the additional tension will be there. So this will break first. If load is gradual or a constant load is applied on this. Not jerk, not sudden load. It's applied, one weight is kept there. Like this, another weight is kept here, which is more. In that case, this wire will break. So option A will be the answer in that case. But they are asking jerk. Jerk means sudden force applied on this one. Sudden force like this. Okay. So if sudden force is applied on this, which wire will break? So in that case, sudden force means jerk. Okay. Means impulse will be created here. And before that impulse transfers from this wire to this wire will break first. Before it transferred to that. That is the answer. So option B is the correct answer. Option B is the correct answer. So portion BC will break. But on internet or somewhere, okay, this answer also given. So you should not, there is a confusion is created. Okay. So this is the answer. Type of load is important. Type of load is important. So we'll see the experiment. Suppose this is like this. Suppose I will apply sudden load here. Look, this broken. Okay, now now we'll see what will happen when gradual load or not jerk will apply. I will not apply jerk, I will apply load. So what will happen? Let us see. What will happen? Let us see. Now look. Now I am increasing the load. This wire broken. Okay, first this wire broken, upper wire AB. So load is applied. Okay, A will break because tension will be more, and sudden jerk is applied. Then impulse will be created. Before the impulse transfers to A, this C wire will break. Okay, so at that time jerk case, option B is the answer. Okay, thank you. Watch it. Watch the experiment again. So this is one string. This weight is attached to this string, and same string, this is one string, let us say AB string, and this is another string, BC string. Okay, so made up of same material. Now question is, if sudden jerk is applied to this string, sudden jerk is applied, which string will break? This second string or this first string? Which will break? That is the question. So there are two opinions. Some will say tension in this will be more, so this will break first, and somebody will say this jerk is given to this, that is why before this jerk get transferred to string 1, this will break. Okay, before it transmits to the string 1. So BC, this second string will break. That is these are the two opinions. So I thought, so one of my students asked me this, sir, there are two answers, so which is the correct? I thought I should perform an experiment. So this is the experimental arrangement I have done. Okay, so here one string I have attached. This is one mass, and this another string of same material, same length. So let us apply jerk on this. Okay, let me try this now. Sudden jerk I will apply. Sudden jerk. Let us. Yes, it is broken here only. Okay, so sudden jerk is applied, then first string will break because that jerk will be transferred there. Before it transferred there, this will break. Okay, now we'll see. Now instead of jerk, I will apply load on this, and now we'll check which string will break, this or first one. Now I am not applying jerk, I am increasing the load now. So in this case, first was break, first is broken. Means when you will apply jerk, second string will break. When you will apply additional load, constant load, it was not constant because I wanted to check, so I increased the load, but when that type of load is applied, tension in the above string will be more and that will break. So this is the solution. Thank you.